Hey folks, thanks for trying science. Today we're going to be going over some of the cool things about solubility that you need to know. If you're at home, you can participate, doing that fact finder sheet. And don't forget, you have some work coming up here. We've got mixtures reading homework that's due. Don't forget, you've got your survivor project due on the 13th. All right, so let's get into our lesson for today, which is all about solubility. Where would we put toothpaste? Solution, suspension, or a colloid? Well, to help you out with that, there's something called Fact Finder, solution, colloid, suspension. You'll see a chart. It's in your packet. What we want to do is make sure we put the examples in the right places. These are now in the incorrect spots, along with the definitions. To help you find the answers, what you're going to do is try to figure out what words best describe a solution, a colloid, and a suspension. Remember, these are the three types of mixtures that are very important for you to know for this unit. So using your notes or your knowledge, if you did the reading assignment, you should have like a little bit of a head start there. But definitely take a pause right now. Please try to put the words in the correct order. When you're ready, continue the video and let's see where they should go. Okay, now we've got our examples and words in the correct spot. Sugar and water is a solution. Remember, solutions have solvents and solutes. They dissolve. Sugar is the solute, water is the solvent. When the sugar dissolves, it is having the smallest of the particles. It will be transparent and clear. You won't really be able to see the sugar. It's a homogeneous mixture. Suspensions, on the other end, are the largest particles that settle out, and that's why we have to shake mustard in order to get that mixture to mix again. Colloids fit somewhere in between, where they have medium-sized particles that don't dissolve, but don't settle out. We don't need to shake or stir our toothpaste. Colloids fit somewhere in between, and they block the light. Okay, today we're going to find out about solubility. In your packet, you'll find some notes about solubility and the curves that go with them. So go ahead and find your solubility notes. Go ahead and fill them in. Pause as you need to, and then continue. Solubility just measures how much of a material can dissolve at a given temperature. So, a solubility curve or graph will plot the temperature versus the grams that will dissolve. Typically, this will be in 100 grams of water. As the temperature changes, the amount of material that can dissolve can increase, and in some cases even decrease. A solubility graph helps us measure the amount of solute that dissolves depending on the temperature. Looking at this graph, you can quickly perceive that substance A dissolves better than substance C. You can dissolve more grams of A than C at all times. And as you increase the temperature, the rate of how much material dissolves increases in all three of the materials. There's a few questions in your packet. Please pause, take a minute, see if you can find the answers. Looking at 50 degrees, substance C can dissolve about 12 grams. The way we find that out is simply by locating 50 degrees on our graph. Now, looking at this line, which represents 50 degrees, we can determine how many grams of a material dissolves just by drawing a straight line as we can from this intersection over to this axis, and we can estimate the amount of material. Substance B and substance C is right there. What happens if you add more solute than can dissolve in a solution? That's when you get a saturated solution. You're completely full. In other words, there's no more material that could dissolve at that temperature. In this example here, there's extra material at the bottom that will not dissolve. At 55 degrees, only a certain amount of this material will dissolve. That's why, even stir as we might, this will not dissolve into the liquid. In order to get this material to dissolve, we may have to increase the temperature. Unsaturated solutions, on the other hand, are possible to dissolve more material at that temperature. And don't forget about insoluble. In means not. A material that's not able to dissolve, such as this oil and water mixture, or something like sand in water. There are many factors that affect solubility. As you watch the video, see if you can come up with 5 or 6 different factors that affect the solubility of a material.
So we're going to learn about factors that affect solubility. Try this experiment at home, or at least think about what would happen if you did try this experiment. Take some sand and stir it into a glass of water, and what happens? Well, the sand just kind of settles to the bottom. Now try taking some salt and stirring that into a glass of water. What happens this time? Well, it disappeared. It dissolves. Some things are able to form solutions with water, and other things are not. The sand did not dissolve, and so it is insoluble. And the salt, on the other hand, it did dissolve, and so this is soluble. And so in this video, we're going to learn about what affects the solubility of things that dissolve in water. Why do some things dissolve better, and how can we make something dissolve better? So we're going to look at 4 factors. We'll look at stirring, temperature, particle size, and pressure. Now before we get to those, one thing to consider is that solids are not the only thing that can dissolve in water. Believe it or not, gases dissolve in water as well, and actually air dissolves into water really well. If you drink a glass of water, you're not drinking pure water, you're drinking water that contains a lot of dissolved substances. Now some of those things are minerals and different vitamins that might have dissolved in there, been intentionally placed in there. But you're also going to get air that's in there. So the oxygen and carbon dioxide and nitrogen from the air dissolves into that water. You can also think about pop. Pop is fizzy because they have put dissolved CO2 into that pop. Gives it that fizziness. So we're thinking about solubility, we're thinking about solids, we're also thinking about gases in some of these. So let's start with stirring. This one's pretty common sense. Have you ever tried to sweeten your tea or coffee with a spoonful of sugar? Well, you can't just dump it in and then start drinking. You have to stir it. Now, if you did just dump the sugar in, it would eventually dissolve. It would just take a long time. So stirring increases the rate at which a solid will dissolve. So another way to put that is we can say stirring increases the rate of the solubility. Next factor that we'll look at is temperature. Now, iced tea and hot tea are going to dissolve sugar differently. You may have tried stirring sugar into iced tea to sweeten it a little bit, and after you finish that whole glass of iced tea, you may have noticed that there's a bunch of sugar left in the bottom, or maybe you noticed it was sweeter at the bottom than it was at the top. Solids don't dissolve very well in cold water, and the hotter the water, the faster or the more of a solid you're going to be able to dissolve. Now, what about gases? Well, gases actually work the opposite. In a hot solution, gases will dissolve less, so they'll be less soluble. And so solids are going to increase their solubility as the temperature increases, while gases will decrease their solubility as the temperature decreases. All right, the next one here is going to be particle size. Now, there is a reason we use granulated sugar to add to our tea and coffee. The smaller the particle size, the faster a substance will dissolve. And breaking a substance into smaller particles gives more surface area to interact with the water molecules and dissolve. And so the smaller the particle, the faster it will dissolve. And finally, pressure. Now, increasing the pressure of a solution is kind of like pushing down the top of the solution. This has very little effect to no effect at all on the solubility of a solid. Solids aren't affected by pressure. Gases, on the other hand, are greatly affected by pressure. The greater the pressure, the greater the solubility of a gas. And this is why pop goes flat when it's left open. The reason pop is so packed with CO2 is because it's under great pressure. That's what it means to be carbonated, is that they pressurize the solution and they can pack a whole bunch of carbon dioxide into that solution. It makes it all fizzy. And when you open the bottle of pop, you're going to lower the pressure of the solution, so the solubility of the CO2 decreases and the pop will go flat. And so those are the factors that affect solubility.
Okay, guys, well, that's the answer to those questions Hopefully that all makes a lot of sense. Work on your homework or project. Don't forget about your project being due quite soon and your homework in Schoology. So thanks so much for tuning in, guys. Been good to see everybody, and thanks for trying science. Okay, see you on the next one.